And we said that this right here was our what? Remember? That's our y-intercept. I also like to call it my start, okay? Because it's kind of like where we start. In other words, x equals 0, okay? If we're running a race and we say, where are we at times 0? Where are you at times 0? Where in a race, you're literally running at times 0. Where are you? At the starting line, okay? You haven't moved yet. This is, and I think I kind of told you the wrong thing yesterday. This is called the constant ratio. There was a quiz question that required you to spell that correct. Okay, but that's what that is. And then the x is just the x. We need to talk about, and we kind of talked a little bit about it yesterday, but today we're going to talk about about growth and decay. Okay, so what I want you to know here, this is the growth and decay model. What do you think A is? It's the y-intercept, or it's the start. How much should we start with? It doesn't matter whether you're talking about growth or decay. Decay means something actually like decaying or going away, and growth means something growing. Either way, you have a starting point. If it's money that you're growing, I don't know, you start with $500. If it's an animal out in the woods, you start with, I don't know, 5 pounds. Okay, and it'll decay. This number 1, I'm sorry?
Animal would decay?
Yeah. Animals decay?
I'm still confused. At 5 pounds?
A full deer dies in the woods.
It's not going to be 5 pounds, it's going to be more than that.
Okay. How much is it going to weigh?
Like 20.
20 pounds. A dead deer in the woods. 20 pounds dead in the woods. Bambi's mom. She'll be gone in like 2 years. Maybe
Bambi's mom was gone in 2 years.
Maybe Bones. No, the hunters took Bambi's mom away. We're kind of getting off topic. So this right here, 1, represents how much do we have. It's, in another sense, it's like 100%. Okay? And then what happens is that we either have a rate that's going to make it get bigger or a rate that's going to make it get smaller. What do I mean by that? This rate right here is also going to be a percentage. If it's a positive, that means it's going to get what? Bigger. So this would be a growth. If it's getting smaller, meaning that it is a negative, it is a decay. Let me explain this again. We're going to have 100% of something, and we're going to add a little bit. That's a growth. And then we're going to do it again. We're going to add a little bit. We're going to add a little bit. We're going to add a little bit. We always have this 100%, and then we add a little bit of it. Or we have 100%, and we take away a little bit. We take away a little bit. We take away a little bit. Okay? That's the difference between growth and decay. Now, I want to be careful here. Down here, I have some examples. I'm going to say, so let's talk about growth. Give me a number to start with. 2. So let's say we have $2. Okay? And it's going to grow. So what will happen is that we're going to have that 1 plus a little bit. What does 1 plus a little bit equal? More than 1. Give me an example. That's a lot more. Let's go smaller than that.
2.
I mean, you're right. 6 and 2 are right answers, but I want to go a little bit smaller. 0.2. Now, it's not, I don't want to write 0.2 here. I want to write what?
2%. I got 20%.
I want to write 1.2. What does that 1 represent? If your money is growing, you have $2.
It's growing by
And they're going to give you a little bit. That 1 right there represents that your 2 is still there. We're just going to add a little bit to it. Your 2 is still there. We're going to add a little bit to it. Your 2 is still there. We're going to add a little bit to it.
So it'd be like
This 1 is the 2, and this 0.2 is the little bit.
kind of like investment.
What I did over here is I simplify this. I get 1 plus 0.2. That's 1.2. Okay? And then don't forget your x. What if I have a mean brother and he says, I'm going to take away 0.2. I'm going to take a little bit of your money away. Yeah. It would be 0.8. Because I did 1 minus the 0.2. So now I have the 2 here. Instead of adding a little bit, I'm cutting a little piece off and cutting a little piece off and cutting a little piece off and cutting a little piece off. Okay? That's the difference between growth and decay. The 1 here says keep it and add a little bit. This is saying I'm not even keeping the 1. Okay? And that's the difference between these two. Someone give me a different example of growth. Go for it. Whole equation. Y equals.
Y equals 5
Start with 5.
parentheses 1.7.
1.7 to the x. Okay? Yeah.
Is it always gonna be like 1 point, like?
It doesn't have to be. If I say it's 5 times, let's say it's 3 to the x. What is my rate there? 2.
$3 for it.
My rate is 2 because I'm giving you 1, and then there's going to give you a bit of 2.
It's always gonna be 100% like 1.
It's always going to be more than 1 because you get your 1 piece plus some more. This is a huge rate. Okay? This is a huge rate. Yeah.
So that's always going to be more than 1, that's always going to be less than
Correct. Except we got to be careful when we say less than 1 because it can't be what?
1.
It's not going to be negative, right? So this can be y, some decay, y equals 3x, or 3, give me a number.
6.
6 would not be right.
6.
Huh? 0.6.
Jeez.
So 0.6. Let me ask you this. What is the decay rate on this? 0.4 is the decay rate
Huh? Because it has to equal 1.
because it's 1 minus something to give me that.
I'm so confused.
Look, so
What's
1,
happening?
1 minus 0.6 is 0.4. So the decay rate is 4.
Minus 0.6 is 0.4.
The decay
So the
rate.
decay rate.
Use this opportunity.
Okay.
So if I wanted to, I could write it out and I could say I'm starting with $1,000 and I'm going to spend some of it each day. And that $1,000 is going to shrink. And let's just say I'm going to say I spend 10% a day. Okay. So then what would the equation be here? 0.9. Because really I could translate this to y equals 1,000, 1 minus 10% to the x. And that's what that would give me. All right, so word problems come up very quickly here. Also, I want to point out, this is going to be hopefully very quick questions for you, and you know how to do that from that. But word problems. The population of Hillville grows. That word grows is super important. That means our constant ratio has to be what?
6.
More than 1. More than 1. At a rate of 15%.
So it's 1.
It's 1.15. Okay? So we want to estimate how much the population will be in 5 years. So our equation, y equals,
I thought the rate was like subtracting 5. They subtracted 1.
when do you subtract?
When it's less than 1.
When it's a decay, when we're losing population. When do we add? When you have more. Y equals, how much do we start with? 5,000. On this little sign right here, it says there's 5,000. Parenthesis. What goes in the parenthesis?
Oh no, 14.
1.15. If we could maybe refrain from just,
Sorry.
okay, thank you. And then to the x power. That's our equation. We want to plug in what? 5. So y equals 5,000, 1.15 times to the fifth power. Purely a calculator question. You can do that in your head. So in 5 years, word problems, word answers. In 5 years, the population will be about, why do I need to use the word about? Okay, about 10,057 people. I would round that up just because it's larger than 0.5.
They've more than doubled their population.
Right. So that percent growth is a lot. So when they say that a state or a town or a city is growing by 15%, that doesn't, for every 100 people, that's 15 people. That doesn't feel like a lot, but it is a lot over time. Okay. School districts, sometimes we struggle with our growth because what does that mean? Not enough space, right? We have to build a new school. We have to build new classrooms. We have to build new things, right? So, and then the opposite, if you're losing people, is actually almost kind of worse. Why is that? You have to, yeah, some schools you'll have to start firing teachers, right? And people don't like to be fired. So.
Oh, I talked to one of the teachers that worked at the place for like the hack got in their Chromebooks.
Oh yeah.
And she said like security cameras, like not just Chromebooks, but like security cameras and like
think about all the everything that's
like
connected.
Cell phones that they have in school.
I mean, we're super dependent on computers.
Like they still have to do exams.
Right.
And then they need to get like a day to like prepare for anything.
Right. Yeah. I mean, what they're trying to say is, hey, this is a situation we're in. We got to move forward, right? And it's.
We gotta be American. We gotta do this.
And so they want to just kind of not say let's take off a month of school. No, let's keep moving. Okay, the population of Value Town is also 5,000, with an annual increase of 1,000 people. Okay. Can the expected population of Value Town be modeled with an exponential growth? Explain. So let's make a table to kind of figure out what's going on here. Okay. So at 0 years, how many people are there?
0.
5,000. That's how many we're starting with. And then after 1 year, we're going to have how many? 6,000. And then after another year, 7,000. And after another one? So what is this? Can it be modeled by exponential? Why? Which means it's what? It's linear. Okay. I saw yesterday someone plotted these points on their Desmos and they looked at them. And when they looked at them, they realized, wow, that made a straight line. That's not exponential. I thought that was a really clever way of figuring that out. But yeah, this is a growth. We can actually write this equation. This is y equals 1,000 x plus 5,000. That's a what kind of equation? This is linear.
Linear, y, and
Luke, will you close your Chromebook, please? So that is not, we cannot do it exponential. So I guess we should answer the question, can it be modeled? No, because it is linear. Okay. And what exponential does is it does grow, but then it not only does it add the 5,000 would it not only would it add the 1,000, but then it would add the next time it would add more to the 6,000. Okay, so it grows a little bit differently. Okay, it's multiplication rather than addition. All right, the Dead Sea Scrolls. Anyone ever heard of these? Okay, Dead Sea Scrolls in 1947. Someone was walking around these caves and they're like, "Hey, look at these old papers." And they were like, "Wow, these are really interesting old papers." They had no idea really how old they were. They didn't know if someone wrote them and like just threw them in there and what was going on. So they used carbon dating to figure out actually how old it is.
We're literally learning about that in science right
Yeah.
Um,
And a piece of it was the linen that was 1.56 is tested and has gone through that much decay. And the initial amount was 2 grams. Okay.
How many
9 out of
senses
6.
is that one?
Help me. What's that? Help me write this equation. So we know it's y equals.
now.
What's that again?
2.
2. I love it because we start with 2.
Then it would be something.
Yeah.
Would it be 15 or 0.59?
It's not. It's not that. And we'll talk in a second. So this is called half-life. And so what we're getting at is this is how many times, how long it takes for it to be what? Half. So if there was a deer in the woods and it was 20 pounds and it decayed, how much would it have to decay for one half-life? It'd be 10 pounds now. And then after another half-life, it would be 5 pounds and so forth. So what our thing is it's really we're figuring out that there's half as much. I'm sorry? It's 1 minus a half.
Oh, right.
Okay. Good point. To the x. And we'll talk a little bit about what that x is here in a second. So it tells us that we started with 2, or then they took this sample. So it had this much, and then it went to this much. Okay. So they're kind of giving us answers of what happened. And then over here, here's all the different half-lives, right? So they picked this one because they thought that it might be about that old. Do you see how this one is 5,730? You wouldn't want to test it in, say, polynomial 210 because that's 140 days. Okay, you want to test it in something that it's about that age. So when they test carbon 14, they're testing things that are about 5,000 years old. Okay, if I realize that it's gone through 2 half-lives, then I could say that. Okay. So if this is how much it is, and then 14 linen test was a 1.45 Gs and tested to find the sample had come through. Trying to think.
Wait a minute. It's gone through 0.4.
Yeah.
And now it's 1.
Gotcha. Okay. So that means that this sample is now this much. What is that 0.14? Yeah,
I don't think that's what it means.
Jasper?
I'm pretty sure that 1.59 grams is yeah.
Say again. In this equation, do you know where that sits?
Because 0.41 is how much is been.
Wait, sorry, you're starting here.
It's how much we have now. So I'm gonna, not that, but the 1.59 is how much we have now.
Yeah.
So this is I plug it in for my y, and I want to figure out
What X?
how many times did it go through this process. So I go to my calculator and I want to try to figure out what X value is going to hit that. Do you remember our trick for this yesterday?
Wait, so we don't do anything with the 0.41?
The 0.41 is saying that's how much is gone, right? Do you notice that if you add these two numbers, what do you get? 2.
Well, I'm saying like in the equation.
We don't. It's just letting us know that some of it's missing and this is how much is left over.
So technically, you could just say that 1.59 was tested and the sample was 2 grams.
Yeah, right. Yeah. You don't need that. This is extra information. Okay. Do you remember yesterday how I said we could solve this? Or not yesterday, when we had notes the other day? I said, let's turn it into a system. Do you remember what our equations were? Okay.
Oh, was it like 0 and 1?
Our system, if I want to turn in any equation into a system, it's my y is 1.59, and what's my other y? I make the left side a y, and I make the right side a y, and I want to see when they're what? The same, when they're equal. So I go to Desmos, and I just say I want to know when y equals 1.59, and my other one is y equals 2 times 0.5 raised to the x. Oh, what did I do?
I don't know.
Raised to the x. Okay, and then boom, I can see right there, instead of playing that game we did the other day of guessing the numbers. So right there, it tells me that my x is 0.331. So I go back to my question. That means my x is 331. That's how many half-lives I've gone through. Okay, I haven't even gone through one yet. Okay, if I went through one half-life, how old would this thing be? It'd be this old. That's one half-life. I didn't go through one half-life. I went through
Half a half-life.
0.331. So how do I say 0.331 of a half-life? You multiply them. So all I got to do here is go 0.331 times this 5,730. Put in the calculator, absolutely. 0.331. And I can see that it is 1896.63. So I can say that this is the scrolls are 1,897 about, I'm going to use about, years old. Okay. And that's what that's how they do that, is they figure out, and what they can see is they can see how much of it has disappeared, okay, and how much there would have been. The thing they hate about carbon dating is it destroys it. So you have this really old document and you got to like cut a little piece off of it to carbon date it, right? If you have just a little piece of something, how many chances you get to carbon date it?
1.
You might maybe once.
But then if you mess up, you have to get another piece.
What if there is no other piece?
Then
Exactly.
that sucks.
Right,
Maybe you really
right. So you got to be very careful with these things.
say absolute
So when they did this carbon dating, they're like, wow, this is almost 2,000 years old. Okay. I believe these scrolls had something to do with Christianity. And so it made sense to them that they were about 2,000 years old. Okay. All right. And that gave them a sense of maybe who wrote them and when and why and what they were for, rather than just thinking someone was trying to be funny and putting something in this cave and making stuff up. All right, we have a little animal.
That's what Pikachu based off of?
That's I don't know. So it's this little animal. There's 144 left.
I just killed 100.
That's how math works. Yes.
Kill a real life
You could
Pikachu.
just easily.
Why would you do that?
The population. Let's refocus. Refocus, please. The population decreasing by 8%. I see 8%. And I'm like, that's not a very big percentage, but we'll see how long it takes for these guys to go away at this rate. And this is what they kind of do. They go, well, if we're decreasing at 8%, we know we only have this much time to kind of save these guys if we want to. Okay. So help me out here. What is my equation for the? Let's raise hands if we want to add comments. Yeah.
Would it basically y equals 144 parentheses 0.2 and then to the x power?
Be careful. This is
Or not 0.2, I meant 0.02.
okay. So we got to be careful because it's 100% minus 8%, which is going to be
Oh, 92.
it's 92%. Right? You had it as 80%. So 0.92. That's less than 1 because we know it's chipping away at it. Okay. We want to see how many will remain after 5 years, 10 years, and 0, or when there'll be 0 left. So I can go to my calculator. Okay, so in 5 years, there's about 95. Okay, so I'm going to make a quick little table here and then we'll answer our question. So 5 years, it says there's about 95. And in 10 years, there's going to be 63. So we have some time with these guys, but if we just let them go, anyone want to guess when we'll have 0? Let me actually, before we start guessing, what's true about this thing, about this equation if we think about it as a graph? When will it hit 0? Okay, when will it do that?
In 23 years.
When they're dead.
When will it hit 0? When will the equation,
Hold on,
not how many are left, when will the equation hit 0?
Okay, so in 5 years, it dropped like
Right, when is that?
5.
Think about the graph. What do we talk about the graph? What do we have?
It's 0 is 0. When the
It's never. It's never. Why?
Because if you do by
It's not just gonna go
this right here.
to 0.
If you have a piece of something and you cut off a little piece, how much do you still have a piece? And then if you have a little piece of that, and then I'm going to cut off a little piece of that. And then I have a piece of that, I'm going to cut off a little piece of that. When will it be completely gone? You'll never mathematically will never be gone. Now, if there is a molecule left and we cut off a piece of that, yeah, we said like you can't do that. We're also going to say that this is going to get so close to 0 that we're going to call it 0. Also, when it gets down to what number do we know that they're doomed? 1. Why 1? Why is 1? You can't reproduce with only one animal.
Aren't there animals that reproduce themselves?
My oceans.
All right, so let's make some guesses of when we think this will get to 0.
That's so.
I'm going to have you two are only allowed to make comments when I call on you after raising your hand. You want me to repeat that? Okay. Does that seems fair, right? Okay. Guesses. of when we get to 0 or close enough to it. Yeah.
Oh, I think it's gonna be
Like how many years?
52.
52.
Actually, 53.
That's actually was a pretty good guess. I thought it would be smaller than that. Okay. Someone else want to guess?
I was gonna say 30.
30, right? Should we guess 30 now?
No.
We don't need to because we know it's more than that. Yeah.
52.7.
I think it's going to be more than 52, but let's see what that does. Okay. Yeah.
It's gonna be like
I have a guess. 60.
60. That's a point. No comments without raising your hand. Okay. So, yeah. 65. And this becomes kind of a weird question because at 60, there's only one left, right? And once there's only one left, technically, it's not going to reproduce. We're going to wait till that one dies. But yeah,
82.
82. Okay, super close. Yeah.
Wouldn't it just be like, couldn't it be like 1.3 because then it's one and less than one other one, and you can't have like a
So you're saying more like 1.49?
yeah, because then it's like you can't reproduce because there's
Yeah.
not.
So then if the question is how long do they live once there's only one, right? But yeah.
85.
85. So mathematically, we can try to get this really close to 0. And you notice it's small and it's just getting smaller. Yeah. 90. So I think that the question is not a great question. Yeah.
160.
Oh, what are you doing?
It really should be asking, what does this E mean?
They're all dead.
What does that E to the -4 mean?
There's zeros. There's one zeros and
So really this is 0.00023, and it's not 4 zeros, it's 3 because, and we'll talk about that later, but that is pretty close to 0. The better question would be not when there are 0 left, but when there are how many left? 1. It's probably a better question to ask when there was 1 left, and that was really close to 60 years. So 60 years is roughly 1. Let's answer these questions. In 5 years, there will be 95 left. In 10 years, there will be 63 left. We also know with biology, when you start getting fewer numbers, then you start having, they start reproducing with their siblings, which isn't healthy in biology, right? Okay. After 60 years, there will only be 1. So there are a lot of questions that kind of come up with these animals in this situation because it's kind of like, do we care about this animal? Okay, and some people feel like Parker, that's a point. Some people feel like that we shouldn't use any energy to help these animals. Okay, who cares if this little guy? I'd never even heard of him until today. Okay, and other people say, no, it's important because it's good to have. We don't want things dying off and never see them again. Yeah.
I'd say that we should put them like in the zoo because I kind of want to see what they look like, and it would help like keep them alive.
In zoos, a lot of zoos' work is on increasing populations of things.
Actually, I was bringing one of mine.
Bring them to your house, all 144 of them. All right. When you buy a brand new car or even a used car, what do you know happens to the value of the car over time? Yeah. it goes down. Okay. So if we buy a car for $20,000, it tells me that it's going to decrease in value 15% each year. Okay. And so can someone give me, Parker, yeah, you want to say something?
I wanted to do it.
Okay. Give me the equation.
So y equals 20,000. Parentheses, 0.75.
Close. It's 15%.
Oh, 85. 0.85.
So 0.85.
Yeah.
And then
And then it'll be
to the what?
x.
To the x. Just so you know, on the homework, the group quiz, it asks you to write the model for each. So here's the model. It didn't ask us in this question to write the model, but it asks for the model in the homework. So it wants you to write the model and then use it. Yeah.
Would that be another equation to the right?
Yeah, you want to do that one?
Yeah.
Okay.
I got, y equals 500 parentheses 1.28 to the x power.
Good. So this is the value of the car, and this is the cost of the car. Cost of maintenance, cost of fixing. A brand new car, how much do you have to fix on it? Very little. You do have to do what after a while?
Like change the oil.
Change the oil. That's a point. Okay, got to raise your hand. Change the oil. After a little bit, you got to fix the tires. But brand new, it's not going to cost very much. When it gets older, all kinds of things could happen. You got to fix the alternator. You got to change the light bulbs. You got to change this, and this. Yeah.
New engine.
New engine. If you get to a point of new engine, they usually say what?
Total.
Yeah, buy a new car. Okay. And totaled, when they say a car is totaled, they're saying that it costs more to fix it than it does to just buy another one of that age. So this is what they're talking about here for total. We want to figure out when these are what? What would you guess?
Total.
Okay.
Not
The same.
We want to know when these are the same. And when these are the same, what should you do with that car?
get rid of it.
Should get rid of. That's the point. Okay. There's metal scrap yards in Columbus. Anyone ever been to the metal scrap yard? Yeah, they're interesting. I have a truck. I fill the truck up with metal. I go in. They weigh me the truck, the metal. Right. I go out. I dump out all the metal. I get back on the scale. They weigh it again, and they say you're 400 pounds lighter now without that metal. How much metal did I drop off? 400 pounds. And then they paid me for that. You can literally drive your car in there, get weighed in, drive in to the place, park your car, and then go step on the scale. And you're selling what to them essentially? The scrap metal. From what? If I drive in there and I get out of my car and then I go stand on the scale,
How much faster
what am I selling?
the car?
The car. Okay. I think they might have some questions if you like do that, but in theory, you could sell it, right? So that would be the most value. Okay. So we want to figure out when these things are equal. What do you think the easiest way to do that is? Put it in a graph on Desmos and find out where they're equal. We're going to run out of time, so we're not going to see that. But what we'd have is we'd have a graph. This one is a decay, so we'd have a graph going down, and this one's a growth, so we'd have a graph going up, and we'd find that point, and we could talk about at that point it doesn't make sense to have this car anymore. It's costing you more than it's worth. Next formula, we have this formula called interest formula. What is P replacing in our other formula? A. What does that A stand for? Which is our what? This is our start. So P stands for principal And principal means how much money you start with. Oh, goodness, money. So if you put money in your bank account, they might say, what's your principal going to be? That means how much are you depositing right now? And then it's got a little bit weird. Instead of 1 plus, and then there's our rate, it's divided by n. Okay? So this is how often, and this n is the same, calculated. Okay? R, what do you think R is? Yeah, we're gonna just call it our rate. And what do you think T is? Time in years. Okay. So what they do is, what happens is you can go to the bank and they'll say, we'll compound this monthly. So how many times a year? That means that it's done 12 times. Okay, so let's look at this problem here. So the equation here, we're depositing, our principal is $3,000. And A stands for amount after that time. We have an interest rate of 8, compounded quarterly. What does compounded quarterly mean? 4 times a year. Okay. So our equation is 1, because we're not going to lose our 3,000. They're going to add to it, plus 0.08 divided by 4 raised to the yeah 4, and we don't use x, though I wouldn't take off points if you did. We usually use t there. And now we figured out our formula, and we can figure out 5 years, 6 years, 20 years, 1,000 years. Okay, so 5 years, 3,000, parenthesis 1 plus 0.08 divided by 4 raised to the 4 times 5. And in 5 years, the amount, which is what A stands for, will be $4,457.84. Okay, we'll stop there. We kind of ran out of time. I just want to make sure we saw that last equation. All of these require you to write a model, so make sure you write the generic form before you start plugging in values. Yeah, so write the equation like we did on all of them, and then try to solve it.